All right, so this is the second part of 2.4. All right, so this is just the absolute value part. Okay, now just kind of a little recap on this. If, here, I'm going to do this on piece of paper. If I had this absolute value of -4, my answer to this would be 4, right? But if I asked you this, what this is asking is what value of x is going to give me 4? Well, I have two values. I can use -4 or I can use +4. If I have the absolute value of -4, I get 4. Absolute value of +4, I get 4. Okay? So what that means is when we're solving absolute value equations, I'm going to have two solutions, or I could have two solutions, right? So that's what this says. When solving absolute value equations, you should always write two equations. We want one that's positive, and we want one that's negative. Okay? And when I solve these, I'm going to follow the same rules that I have over here. I want to isolate the absolute value. That's going to be the very first thing. So there's no space over here, but number one is going to be isolate the absolute value function. Okay? So if I look at this one, this is isolated. So this one's good. It's all isolated. So now I'm going to write two equations, one positive, one negative. So if I write a positive equation, I'm going to make this my positive equation. I'm going to just drop my absolute value bars and rewrite it. No change. If I want to write my negative, I'm going to drop my absolute value bars, and now I'm going to make everything equal a negative number. Now, I said negative number. It's not always going to be a negative number. It's going to be whatever this opposite number is. Okay? So let me go over this one more time. I have this isolated. I drop my absolute value bars and I make it positive. That's my positive solution. My negative solution would be if this value is a -7. And now I solve it just as normal. So I'm going to add 5 to both sides, and I would have that x equals 12. And over here, I'm going to add 5 to both sides, and I have x equals -2. So here are my two solutions. X equals 12, x equals -2. But I have to test it. So if I plug it up in here, I would have 12 minus 5, which is 7. So this one's good. I plug -2 in here, and I have -2 minus 5. -2 minus 5. And this is -7, but the absolute value of -7 is 7. So this one's also good. Okay? Now, with this guy, I want to isolate, so I'm going to divide this side by 5. Divide this side by 5, and so what I end up with is 5x minus 10 equals 9. That's my isolated equation. So now I make one positive and one negative. 5x minus 10 equals 9, and 5x minus 10 equals -9. So if I solve this, I would have 5x equals 19. So x equals 19 over 5. On this side, I would have 5x equals, if I add 10, 1. So x equals 1/5. Okay. Now, initially, that looks like yucky numbers, right? But when I plug this in, because I'm multiplying this x by 5, that means this goes away. So that's not bad. So when I plug this in, I would have 19 minus 10, which is 9. 9 times 5 is 45. So I'm good. If I plug in 1/5, let me do this one over here. So I would have 5 times 1/5 minus 10. So this would be 1 minus 10, which is -9. It's in the absolute value bar, so it becomes a +9. And then I have to multiply it by 5, which is 45. So both of these are good answers. Okay. All right, let's go to this next one. So actually, I'm going to pause the video and you do number 3, and then we'll come back. So you do number 3. Okay, so I got 5 and -11 over 3. And I checked both of those, and both of those work. Okay? All right, let's look at this next one. This next one is so simple, I'm only going to write one thing. So no solution. So hopefully you see why it's no solution. But the bottom line is there is no value within the absolute value bars. There's no value that'll ever give me a negative number. So because I have this -5 over here, this is no solution. Now, if I did the math, I'm going to end up with an answer. And then when I go back and check it, it's going to show extraneous. But if you see this right from the start, then you're done. You don't have to do any work. All right? So with this guy, we're going to do it the same way, even though I have a negative number on, or I have a variable in there. So this is isolated. So what I'm going to have is 2x plus 12 equals 4x. And this is going to be my negative side over here. I have 2x plus 12 equals negative 4x. So nothing changed. Doesn't matter that I have a variable in there. That doesn't matter. So if I move this around, I would have 12 equals 2x, so x equals 6. If I come to this side, I would have 12 equals negative 6x, so x equals -2. So let's test this. If I plug it back in, this is going to give me 12 plus 12, which is 24. So 24 equals 4 times 6, which is 24, so that one's good. Over here, I would have, let me write this one out. I'm going to have -4 plus 12. This is in absolute value bars. -2 times 2, so -4 plus 12. So this is going to give me 8. On this side, I'm going to have 4 times -2. This does not equal 8. This equals -8. They are not equal. So x equals -2, this is extraneous. So I'm only going to have one answer. Okay? All right. I'm going to go ahead and pause the video, and I want you to think about what you're going to do for number 6. Okay, so this one's a little tricky. If you looked at it at this step, at step 1, right here, if you looked at this and you said no solution because it's negative, that would be wrong. And the reason for that is because we're multiplying it by some value of x. So if x is a negative number, then you would have a negative times a negative, which would be positive. Okay, so we have to solve this and see what we get, because if x is negative, it's going to work. So I have a negative value, so this -3x is negative. So if I break it out like I've been, this is my negative side, this is my positive side. Nothing changes. This one I have to take the opposite sign, so I went from a negative to a positive. When I solve it, I got x equals -1. I checked it, it works. Here I got x equals 5. When I plug it in, I got 15 equals -15. And that's not true. So we know that this one is extraneous. All right. A couple more here. So here we've just added on some some more steps here. What I want to do is I want to isolate this absolute value first. So I have 3 minus 5x, which is going to be -7x minus 7. So I took this 7, I moved it to the other side. Well, now I'm going to do the same thing that I've always done. I'm going to have one positive and one negative. So I'll have 3 minus 5x equals -7x minus 7. Okay, nothing changes. Now for this one, this negative means I'm multiplying the whole right side by a negative number. So I drop my absolute value bars, and then I have 7x plus 7. So this became positive, and this became positive, because really I'm doing this. I'm taking my answer that I have over here and I'm multiplying it by a negative. And when I do that, I get two positive numbers. So if I solve this, I would have 10, move that over, move this over, minus 2x. So x equals -5. And with this one, I would have -10 equals 2x. So this tells me that I also have x equals -5. Let me make sure I did this right. -10 plus 2. Okay, so I have this value of x equals -5. So now I want to go up here and I want to test it. So this becomes 3 minus 25. And 3 minus 25 is 21. No, sorry, 22. 22. But it's in the absolute value bars, so it doesn't matter that it's -22. When I add this with 7, I get 29. Okay, and this side is going to be -7 times -5, which is a positive 35. Make sure I did my math right on this. 3 minus 25, which is minus 22, becomes positive 22 plus 7. Okay, so that doesn't work, right? When I do the math on that, that doesn't work. Okay, so this side over here is going to be no solution. I'm going to pause it, and I want you to work number 8. And think about number 8. Let me give you a clue. I'm going to have a positive and a negative, so positive doesn't change, but negative is really going to be this. Okay, so do that and then come back and check. Okay, so solve this. I got x equals 4. When I plug this in, I show that this is extraneous. And then I plugged in 6 over 7, and I got an answer for that one, so we're good. So let's go back to this one, because it wasn't sitting right. So I worked the math just now, and then I realized I was talking and my computer wasn't on. So when I did this, I'm doing too much of this in my head. I'm not writing enough down. So when I solve this over here, when I move this 7 over, I get -4, and I move this over, I get 12x. So I would get -1/3. And so when I plug in these two numbers, I realized I plugged them both in wrong. So if I do this, I'm going to do this again. This time I have 3 minus 5 times -5. So this gives me a positive 25 plus 3. So this answer is going to be 28, not 22 like I had up here. So 28 plus 7 is 35. So this is an answer. It's not extraneous. It is an answer. Okay? And then when I plugged in this 1/3, I did the same thing, but this one is extraneous. So I guess the bottom line on this is this was my bad because I was trying to do this in my brain. So make sure you're showing your work so that you can see if they're extraneous or not. Okay? Let's answer this last question. We'll be done. What do you notice that's different about the equations in examples 5 through 8 versus 1 through 4? Okay, so should be easy for you to see this is that we have variables on both sides. And why that's important is because if I have that, I could have something that looks like this, where I can have a negative value on the right side of the equation. On the non-absolute value side, I can have a negative value because my x value might be negative. And then this is super simple in my case. When should you check your solutions for extraneous? This is going to be always. But especially if you have an x outside of the absolute value bars. Okay, come see me if you have questions. Otherwise, I'm going to give you some stuff to practice. Thanks.